Dear students, let us start the first lecture of this course. This is basically a online course. So, therefore, you need to be very clear about what you are going to learn and how you are going to be evaluated. First of all, this is a course on phase transformation in materials, and I will be teaching all the lectures, and it is a 30 lecture course. That means there will be 25 minutes lecture, and every week you will be exposed to, I am not sure now, about 4 to 6 lectures. So, that means about 2 to 3 hours of lectures. So, myself is Professor Biswas, and I am a faculty member at the Department of Material Science Engineering of IIT Kanpur. So, that is the details about me. My email address is available on the screen. You can directly write to me whenever you have any serious problems. And in addition to that, to handle the course, exams and also grading of your answer sheets, although I know this will be all done online, will be taken care by the teaching assistants. So, 2 of my students, they will be handling that. So, they are actually the main person who will be handling your questions. To my right, first one is Khushbu Tiwari, she is my PhD student, and second one is Resma is also my PhD student. So, they will be handling all your questions in a discussion forum. Obviously, if they are very difficult, then I will also participate, and also they will be handling your question paper and grading. So, my task will be to deliver all the lectures, and then this will be uploaded into the NPTEL website, so that you can observe and read or listen or learn whatever way you can think about it. Nowadays also there is another provision, all my lectures whatever I am speaking will be again taken down or written by some experts. So, we are in the process of finding out those experts for my earlier course on phase transformation in materials. Similarly, we will do it for you also, so that you do not need to listen, you can actually read all these lectures notes. So, before that happens, you are going to only listen these lectures available on the NPTEL forum, and also you can ask questions in the discussion forum. And so, that is about it, and their email addresses are given, and I have carefully removed the phone numbers, because this is where things become very difficult to handle. So, if you have any questions, you can ask them, ask me also, or you can put it on the discussion forum. Okay. Like any things in life, every course has an objective, and this objective has to be very clear before you start a course. So, present course actually will deal with basics of phase transformations in materials. As I said in my introduction video, already you have seen probably, that phase transformation is everywhere present in the environment, whether you are talking about metals, ceramics, polymers, or you are talking about real life, phase transformation is present. But how do you deal with phase transformation? That is what you will be taught, because that is what is important in your endeavor to learn phase transformations. So, using these 3 things, one is your thermodynamics, then kinetics, and some basic aspect of material science like crystal structures and interfaces. We are going to study various solid to solid and liquid to solid phase transformation. As we know, this is a vast subject, and covering it in 30 lectures is not an easy task. So, obviously, we must be selective, we cannot teach you everything, and to learn everything you need to have some basic idea. What I put it as course prerequisite. Okay. These prerequisites are, you should have, preferably should have some basic knowledge on basic material science that most of the students in metallurgy or material science normally have, thermodynamics, especially the thermodynamic functions and their relationships, and then some idea of phase diagrams and diffusion. Okay. So, I have already checked on different portions of the NPTEL. What I mean by different portion is that there are some courses which are video, some courses which are web, some courses which are massive open online. So, basic material science has already been taught by some faculty members, thermodynamics is already been available, and phase diagram I myself has developed a course in the just 1 year back. Diffusion is also partly taught. So, therefore, you can actually clear your doubts by reading these lecture. Okay, this is the full rather all the description of all the lectures. Okay, I do not know whether everything is coming in the screen or not, but anyway, most important thing is that we are going to talk about some very at the beginning we are going to give you some idea about free energy, because that is the thermodynamics part of the phase diagram. So, we will show you the calculation of delta G of various transformations. Okay. Then we will talk about quite a bit about interfaces. Interfaces means liquid solid, solid solid, grain interface, interfaces. These are all parts of the thermodynamics. Then we have to go into kinetics, that is the nucleation, because nucleation is what is the starting point of phase transformations. So, therefore, theory of nucleation, homogeneous heterogeneous nucleations and nucleation on the surfaces, grains and even grain corner, grain edges everywhere, it will be dealt with, and as you know nucleation itself is a subject. So, therefore, you must be very you have to be very careful about what you are going to talk about it. So, I will not be able to tell you every details of the nucleation, but whatever relevant we will discuss. Then we are going to start the first of the phase transformation, that is on solidification. As you see here, solidification is a liquid to solid phase transformations. Then we will talk about growth during different aspects like thermal activated growth, interface control growth, diffusion control growth, that is why you need to know, and as well as coupled growth in eutectoid or eutectic transformations. Then we will talk about little bit about transformation kinetics in terms of different models, Johnson and Abrahami models, and some amount of the thermal phase transformations. Then we simply go on to different solid to solid phase transformations like precipitations, recrystallization, martensites, spin order decompositions, and a bit about isothermal and continuous transformations. That itself will be sufficient enough to cover 30 lectures. Okay, so, this is important that you know what you are going to be taught at the beginning, so that you can prepare yourself. So, we are going to follow exactly the same way things are given. On the right side I have also listed down number of lectures will be spent on each topic. Now comes the very important aspects, because in a massive open online course you will be exposed to video lectures or the online lectures. You must have some amount of textbook knowledge. So, therefore, two important textbooks which I have carried from our library is this first one, which is here, is written on that, is phase transformations in metals and alloys. Classic textbook by D. A. Potter and K. A. Sterling, and a recent edition also has come with a new author. All the problems are solved by Dr. M. Sharif. This is available in India, not very expensive book, you can read that. And the other book is written by two of my past colleagues, although I have never met them, but they are IIT Kanpur. This book is Phase Transformations in Materials, and by Professor A. K. Jaina and Professor M. C. Chaturvedi. Both were at IIT Kanpur. So, when these books were written, Jaina was in Kanpur. Okay. So, these two books will be your basic textbooks for the course, and any of these books will be good for you. You can buy these books, or you can actually copy from different libraries in the different parts of the books. You can copy from different libraries, or if you want, you can actually even get buy that on different online stores, correct. So, that is about the basic part of the course. I think before I could move on to the next portion of my lecture, why the phase transformation is relevant, let me tell you, you will be given assignments in every week, and I think assignments are normally uploaded on Thursday, and because Monday to Wednesday you will be exposed to the lectures, and after that you will be I will be or my TS will be uploading the assignments, and you will be given about 1 week's time to complete the assignments. Because assignments will be online, so the questions will be multiple choice type or maybe fill in the blanks type. As assignment will have a weightage of 50% weightage, and at the end of this semester you will be taking an end sem exam, and we are planning to have it online so far, if I do not change my decisions or something else happens. Otherwise, it will be online, and that will be having a 50% weightage. Although I am not keeping any pass marks for this course, but you can tentatively consider if you are getting less than about say 30% of the marks, then you will not be able to pass this course. And those who will be successfully completing this course by taking exams and getting good marks will be given certification from the NPTEL, as you know. So, that way I expect that you will be very serious learner, and you will be also able to solve these problems. If in case you have difficulties, you can always discuss, we can always use discussion forum, or you can write emails, you can always bring it to the instructor or the TS, so that we can make it clear to you. That is very important, because unless and until you know the things very well, you will not be able to answer the questions. Now, in the next few slides, I am going to talk about what is the relevance of phase transformation, materials development. And why do you study? In any course, I know that many of you do not exposed by the instructor in the same way. You must have an idea why you are studying this course, what is the need. Well, phase transformation, as I said, is present in environment. Okay. This slide I have taken from literature, that is what I am going to answer to you, why study phase transformation in material science. Okay. What we are actually we look material for, the application. In any case, finally we have to think of application. Unless and until this material is applied, engineering point of view, we do not find any reason to study. Scientific point of view, one can study. So, application means we must know their properties, all kinds of properties, whether it is a physical, mechanical, electronic, electrical, magnetic, depending on the applications. So, property or properties of a material are estimated very rigorously to find and potential applications. This is true for even new material when it is developed. So, now question is this properties, as I said, mechanical, chemical, electrical, magnetic, thermal, you can even list down many more. Properties of the material depends on structure, and that is why actually real problem comes. Structure has length scale. You can simply say atomic structure. Atomic structure is the smallest structure you can think about it, atom and nucleus. In fact, that is what dictates most of the properties of the material, but that is not all. That is what this is what you must know very clearly, that is not all. So, structure means it can be atomic structure, molecular structure, grain structure, phase distribution and defects. Okay. So, we have basically I have listed down from the bottom up. The atom is the smallest species, and then we have grains and other things. So, you must have, I am stressing again, you must have a good idea about the structures to correlate with the properties, because it is important that the properties are primarily dictated by the structure. So, if I know the structure, I can dictate the properties. So, you got the correlation, right. Now, very logically speaking, we make materials, rather we use processing techniques to make materials, and these processing techniques allow you to control structure. Processing technique means what? You can start with a liquid and solidify, that is what is solidification. You can start with a metal piece deform by rolling, forging or extrusion, whatever different means. So, you actually process, or you can actually deposit thin film, you can actually use surface treatment techniques, many things we do in the real processing of materials. They have a direct connections with the structure, and structure has a direct link with the properties. So, as you see here, these actually are variables for the processing: temperature, pressure or stress, strain or volume, and chemical composition for the alloys. You can change chemical composition by making different alloys. So, these are my variables in processing, and by applying these variables or combination of variables, I generate or I make materials or manufacture materials, and these processing variables control the structure and structure controls the properties. So, therefore, these three are linked, very clearly they are linked, they are not separate or they are not independent things, they are connected to each other. So, that these are the bridges of these three important pillars of material science: processing, structure and property. But finally, what do we look for? Finally, we look for what is known as performance. If you are studying in a course syllabus, in a course, we are finally evaluating your performance. Similarly, materials are evaluated in terms of performance. If I put a tire in your car, that means the major performance is that tire should be able to take the car from one place to other place without any problems. But you know, tires will vary from a summer to winter in the foreign countries, and the tires which will travel on ice are different. So, that means performance indeed are actually connected to all these three things: processing, structure and the properties, and that is what is important. This chart, which is very famous in material science, you will find in many books, is known as the materials tetrahedron, because they are actually looks like a tetrahedron. So, finally, where does the phase transformation comes? It is in the structure. We modify the structure, we modify the atomic structure, we modify the grain structure, we modify the phases by phase transformations. So, therefore, phase transformation is a direct link with the processing and also indirectly connected with the properties, and that is why it is a very important course in the material science and engineering. You must understand that without knowing the phase transformations, you cannot control material properties. Okay, so, phase transformation, periquilibrium or thermodynamics is the basis for understanding a material response to change in temperature, pressure, composition. I must accept this is slide I have taken from web, this is not mine. Thus, the critical link between processing and microstructure requires a knowledge of the relevant thermodynamic principles, and they are the basis for phase transformations. So, you understand now why we are actually studying the phase transformations. Okay, now question is this: can I relate in the real applications? I have taken 4 applications, again directly taken from the internet sites. First one is an airplane. Okay, airplane is a very important mode of transport from one part of the world to the other part, and you know, the material which is used in the airplane is an aluminum copper alloy. If you do not know, you can actually check on the books. This is a classical alloy, aluminum 4.5 to 4.7% copper, known as duralumin in the trade name, and this is a very stable alloy from 45 degrees Celsius to minus 65 degrees Celsius or even minus 80 degrees Celsius. I do not know how many of you read news that there is a research laboratory in the southern hemisphere, that is in Antarctica, and sometimes if somebody is ill in the research laboratories in winter time, they are actually taken from that place by plane to the mainland, the different continent, especially in Southern America or some parts. But it will be extremely cold, minus 60 to minus 80 degrees Celsius temperatures. So, a plane flying there The material has to withstand such a low temperature. So, this wonderful material which is prepared long back is used for the plane body. And important phase transformation which is happening here is a precipitation of certain phase in aluminum alloys, and these precipitates provide the strength from high to low temperature. If you travel carefully on the planes, you will find, especially on the wings, riveted joints, and these riveted joints are very strong at low temperatures because of the precipitation. So, we are going to discuss about that. Next one, which is very important on the right side, is a turbine. Basically, it can be used in the plane, the high speed plane, or even in power generators, and they contained nickel based superalloys. This wonderful material is a nickel aluminum alloy with consisting of many other elements, which I will not discuss in detail now, but again the real high temperature properties, because this is a turbine. So, therefore, this has to withstand high temperature. High temperature properties, creep resistance properties of this material is basically because of precipitation of Ni3Al type L12 precipitates, what we known as in a nickel matrix, FCC matrix, and these unique precipitates actually provide the strength. Okay, that means the precipitation is very important aspect to understand. So, that is what will be part of the syllabus. Then on this side, left side, I do not know, maybe you are right, this is the rails which is used to as a fish plate on the railway tracks. These are actually steels, basically the steel of perlite, what we known as. If you do not have any idea of perlite is nothing but a eutectonically transformed product of gamma solution of carbon in iron. And so, therefore, we must know how this transformation happens, whether can we control it, because the properties of the rail depends on that. Remember, rail is what is allowing us to move trains. So, therefore, they are subjected to stress, temperature, harsh environment, and many other things. So, they must have combinations of properties so that they can serve the purpose, and this is basically done by controlling the phase transformations. On the right side, this is the end, the last example is basically the titanium based alloy engines. Okay, remember, these engines are not used in car, they will be used in the planes or maybe in some other strategic applications like the submarines or so. So, these engines actually has many plastic, titanium valves, titanium MMC pins, titanium MMC crankshafts, many other things, springs, and they are titanium aluminides. You know, titanium, out of these all titanium alloys, the most important alloy which is extensively used is titanium 6 aluminum 4 vanadium, and we can control the microstructure of these by many ways, creating alpha titanium, alpha plus beta titanium, beta titanium alloys. So, the properties will vary depending on whether it is alpha, alpha plus beta, alpha or beta. Remember, alpha is hexagonal close pack structure, beta is BCC structure. So, titanium actually at room temperature below 882 degrees Celsius temperature is basically alpha, above that it is having BCC structure. So, one can actually play around in the temperature zone by again controlling the processing parameters to create different kinds of structures to get different properties. So, all these application, do not think that they are all similar alpha alloys or beta alloys or alpha beta alloys, they can be combinations of many of these. Then the actually real problem is how do I control these microstructures by controlling the processing parameters. So, remember, these 4 examples are not exhaustive, one can find many examples in real life. As I told you in my first introduction lectures, the basic example we always find is in country like India. In a hot summer day you want to drink cold water. So, you can always put the water inside the fridge and get it cooled, but it is real advantage is that if I take a glass of water and I add a ice cube taken from the deep freezer, immediately the ice cube will start melting it down or getting dissolved in the water. Both are actually H2O, one is a solid H2O, other is a liquid H2O. So, therefore, by melting it down, the heat is getting transferred to the liquid and then the water gets cooled down, you enjoy the drink. So, this is the example which is present, which you are actually doing it, but what is important for you to understand how this transformation happens, how the solid become liquid, liquid becomes solid, whether it is very simple or no. Remember, water is one of the most complex systems in the world. I mean, unlike metals, this is more complex. So, let me just stop here before I go to the next part of the lecture or the next class. So, you understand in a nutshell that phase transformation is basically very important from the perspectives of material science and technology, and many of these products which you are actually using, their properties are controlled by controlling phase transformations. We can do that by using different processing parameters, temperature, stress, strain, compositions, and by doing that we alter their microstructure, their atomic structure, and by doing that you are creating different properties. So, that is the relevance of phase transformation course, and which you will be exposed to in the next subsequent lectures.